Hello students, very good afternoon. This is Mayur S. More, your chemistry tutor. I welcome you all. As we all know, NEET exam has been scheduled on 12th of September. On the grounds of that, Practically Live has brought you exclusive NEET Crash Course where we have already reached to the 13th session. Maybe a 13th or 14th session, yeah. We have reached to that much session. We have covered that much session. Now we're gonna start with the some of the inorganic chemistry chapters. Okay, and today we're gonna cover the chapter called D and F block element and surface chemistry. Okay, so let's begin. Very good afternoon, everyone. So the very first question: for a catalyst, which condition is not essential? For a catalyst, which condition is not essential? Now, as you all know, what is mean by catalyst? Catalyst is a substance which increases the rate of reaction. Catalyst is a substance which increases the rate of a reaction without itself being consumed in the chemical reaction. Catalyst can increase the rate of the reaction, but the prime condition is that it should not involve with the chemical reaction. That means whatever amount of catalyst you have added initially, at the end of the reaction, same amount of a catalyst should be recovered. That is the condition for any compound to be behaved as a catalyst. Now whenever catalyst involves with the reaction, what happens is that, see, let me tell you how does actually catalyst behave. Suppose you are performing a reaction A plus B, okay, which gives you C plus D, okay. That is your normal reaction. Now this reaction is without catalyst, and suppose without catalyst, suppose it takes the time around 50 minutes. This reaction take time of 50 minutes to happen, okay. Now in the second reaction, what did I do? I added a catalyst here. Whatever that compound could be, anything, it could be any metal whatsoever. Okay, I added a catalyst. It gave me C plus D. Now your time was reduced to 20 minutes. So you have saved a time of 30 minutes. So since you have saved a time of 30 minutes, obviously you have saved quite expenses on the resources also. Now that is not our point here. Our point is that whenever catalyst did this, what does catalyst do? Catalyst on its surface brought A plus B together for them to react faster to give you C plus D. That is the main objective of a catalyst. And while doing so, catalyst combines with reactant, okay, converts them to the product, and at the end of the reaction, it gets away from your product. So whatever happens in this process, the catalyst changes its oxidation state quite often. Sometimes your catalyst gets oxidized. At the end of the reaction, it gets reduced back. Or at the start of the reaction, it gets reduced, and at the end of the reaction, it gets oxidized. Its physical form can change. Chemical form doesn't change that much. Okay, so these things can happen. These things can happen, but for your compound to behave as a catalyst, it should be able to exist in a different oxidation state. Now, as far as D block elements are concerned, the D block element shows variable valences. They show the variable valences. They show the oxidation state from ranging from +1 to +8. Now, by that, I don't mean that every D block element shows all the oxidation state, but most of them does show, most of them does show the range of oxidation state. And that is very important condition for that. That is very important condition for a given compound to behave as a catalyst. That is why variable valency is an important condition. Okay. Second, high ionization energy. See, this condition is actually not required. Your compound should have a low ionization energy. Sometimes whatever ionization energy it has, it doesn't matter at all. Okay. Thirdly, empty orbital. It does needs to have empty orbital. Why? Because these electrons from your reactant goes into the empty orbitals of your catalyst, and your catalyst actually made your reactant react in that way. And lastly, the most important condition, prevalency on the surface. Prevalency on the surface. See, whatever your reactant has done with the catalyst here, this is your catalyst surface, okay, and your reactant has got adsorbed here. Your reactants had got adsorbed here, okay. So for that adsorption to happen, your catalyst needs to have free valency on the surface. It needs to have free valency on the surface, then and then only adsorption can happen, okay. So D is required, C condition is required, A is also required. High ionization energy, it is the only condition that is not required, and they have asked us that only for a catalyst which condition is not essential. That is why in this case our answer is B, okay. So moving ahead, which element is having lowest melting and boiling point? So we have a titanium, copper, zinc, manganese. Okay. Now I have made you understand what are the conditions that are not required for a catalyst, and I need a space for you to make you understand the lowest melting and boiling point. For that, I need to rub this. So I'll rub it down. Okay. Now, see, if you write all the D block elements as far as the 3D series is concerned, because the series that they asked here is the 3D series: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Okay. As far as D electrons are concerned, you got D1, D2, D3, D5, D5, D6, D7, D8, right? D10 and D10. These are the system that you have. But copper does have 10 electrons, but in the form of s electrons, it has one unpaired electron. Let me write the unpaired electrons also. Unpaired electron is 1 for the scandium, 2 for titanium, 3 for vanadium, 5 for your chromium. In fact, not 5 actually, 6 for the chromium, 5 for the manganese, 4 for the iron, 3 for the cobalt, 2 for the nickel, 1 for the copper, and 0 for the copper. Now remember the melting point and boiling point here. Your MP and your BP are directly proportional to number of unpaired electrons. Number of unpaired electron. That means higher the number of unpaired electron, higher will be its MP, melting point, and boiling point. Okay. If you have less number of unpaired electron, your melting and boiling point will also be less. As far as zinc is concerned, zinc has 0 unpaired electron, because of which the lowest melting and boiling point in this case is for the zinc, and that is why your answer is C. Okay. Next, the density of which of the following element is highest? Density of which element is the highest? Now, if you write where does this element belongs to, okay, you already write scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, zinc. Then you have yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, right? Palladium, silver, cadmium. After that, you have a lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, Au, Hg. Okay, these are your elements. Now, as far as density is concerned, mercury is having a very high density. Okay, but there is a one metal which is having further higher density than the mercury, and that metal is platinum. Now, this is a memory based question. You need to remember there are some questions which will come in this section which are memory based also, and this is one of those. Platinum is having the higher density than your mercury. Okay, chill. Moving ahead. If you have any doubt with this, you can ask me in the comment section. Okay, there will be many questions which will come from the memory section. Okay, next question. The adsorption of a hydrogen by a platinum black Adsorption of a hydrogen by platinum black is called. It is not hydrogenation, that's for sure. It is not hydration, it is not oxidation, it is not reduction. What remains is occlusion. It is called as occlusion. It is a specific term which is used exclusively for the adsorption of hydrogen by platinum. Okay, next. To which of the following series the transition element from Z39 to Z48 belongs to? Now, let's understand what could be it. Could it be 3D series, 4D series, 5D series, 6D series, what? See, first we write scandium to zinc. Atomic number of scandium is what? It's 21. Atomic number of your zinc is 30. Okay. After that, you have a 6 p block elements. After that, you have a 31, 32, 33, 34, 35, 36. All of these are p block elements. Okay. After that, you have a 2 s block elements here. Here you got a 37, 38, and then you got a yttrium, atomic number 39. So then you are going from 39 to 48. So this first series where the penultimate electron, was going to 3D. And that is why scandium to zinc, this series is called as 3D series elements. So obviously the very next series has to be what? 4D series. Okay, because it is a series which is just after the 3D series. So if in the 3D series electrons are moving or electrons are getting filled to the, what I should say, 3D orbital, in this series electrons should be filling into the 4D orbital, and that is why this series where 39 to 48 is called as 4D. Okay, moving ahead. So therefore here the answer should be 4D series, which makes B option to be correct option. Okay, I hope it must be very clear with you. You must be enjoying also. Okay, if it is clear with you, let's move ahead. If you have any doubt, you can ask me in the comment section below. Okay, so moving ahead. Chromium forms most stable compound. Chromium forms most stable compound in the following oxidation state. See, as far as chromium is concerned, let me tell you how does actually chromium looks like. This is your chromium, atomic number what, 24, right? Its electronic configuration is argon 4s1 3d5. Okay, so naturally what we think is that it is a d5. d5 is what? d5 is a half filled. d5 is a half filled, and being a half filled, it should be quite stable, right? So after losing just one electron, because whenever it loses one electron, this electron goes, then your chromium should look like chromium argon 3d5 plus 1. Okay, but this is less stable. Even if you have a d5 like this, 1 2 3 4 5, how do you fill 5 electrons? 1 2 3 4 5. Okay, so this your chromium can lose further 2 electrons to give you chromium 3 plus. Now chromium 3 plus is what? It's a 3d3. Now in reality, this 3d3 of chromium, where chromium is in a plus 3, is more stable. Your chromium is more stable in a plus 3 than it is in a plus 1. Now you might ask, sir, why? Because in a plus 1 it was a half filled d orbital, and we all know half filled orbitals have extra stability. Yes, that is true always. Half fills will have extra stability, but see, between plus 3 and plus 1, whenever you are talking about these oxidation states, plus 1, plus 3, or whatever oxidation state that we are inferring to, see, this oxidation state exists in what? They exist in a aqueous solution. They exist in a aqueous solution. Okay. Now what actually happens in an aqueous solution? Let me tell you. See, this all happens in an aqueous solution. Now in aqueous solution, your Cr3 plus gets solvated by water, and your Cr plus 1 also gets solvated by water. Now you tell me, between plus 3 and plus 1, which has a stronger charge? Between plus 3 and plus 1, plus 3 has higher magnitude of charge. Since it has higher magnitude of charge, it can be stabilized to the more effective way by water, making it to release more hydration energy. And when it releases more hydration energy, obviously Cr3 plus becomes more stable than Cr plus 1. That is why, as far as chromium is concerned, Cr plus 3 is the most stable oxidation state for chromium. Okay, that is why in this case answer is C. Next, not more than one oxidation state is shown by which element? Okay, now again we need a little bit space here, so I need to rub this down. Yeah, so what they're saying for this answer is this: not more than one oxidation state is shown by. Okay, let's take one by one. Manganese, atomic number of manganese is 25. Electronic configuration, argon 4s2 3d. Okay, so these two electrons can be loose by it. Manganese can exist in a plus 7, and we know the compound of manganese called KMnO4, right? In KMnO4, the oxidation state of manganese is plus 7. Here it's plus 2. Manganese has one more compound called MnO2, where the oxidation state of manganese is plus 4. So it must be quite clear to you that manganese does not exist only in a one oxidation state. So manganese cannot be our answer. That's for sure. Then chromium. Chromium we just saw in the upper example, right? That chromium can exist. In fact, chromium doesn't exist in plus 1. It can exist in a plus 3. It can exist in a plus 7. Plus 7 where? Sorry, not plus 7, my bad. Plus 6, K2Cr2O7. Here chromium is in a plus 6. Here it's in a plus 3. So chromium can also exist in a 2 oxidation state, and they're asking which element does exist only in a 1 oxidation state. So chromium cannot be our answer also. Then you have a iron. What is the oxidation? Sorry, iron. Again, atomic number 26. Electronic configuration, argon 4s2 3d6. We all know that iron can exist in a plus 2. Okay, it can exist in a plus 3. It can exist in a plus 4. So iron can show 3 oxidation state. So iron can also be not, can't be our answer. Last, scandium. As far as atomic number of scandium is concerned, the atomic number of scandium is 21. Its electronic configuration is argon 4s2 3d. And scandium prefers, what did I do? Yeah. Scandium prefers to lose all 3 electrons, and it can exist in a scandium plus 3. And scandium plus 3 is the only oxidation state. Scandium plus 3 is the only oxidation state of scandium. So that is why not more than one oxidation state is shown by scandium. And therefore, scandium is our answer. Okay. I hope it must be quite clear to you now. Okay. Chalo, moving ahead. Now, next question. Now, obviously, I need a space for this question also. So I'll drop this down. Yeah. So for this, answer was this. For here, answer was this. Now, next question. Which pair of ion is colorless? Now, let me tell you, for any compound to be colored, it should have at least one d electron. It should have at least one d electron. That means colorless compounds. Colorless compounds are either D0 or D10. So D0 and D10 systems are colorless. Okay. So let's see one by one. Manganese, cobalt. Manganese atomic number is how much? 25. Electronic configuration argon 4s2 3d5. Out of which it's a plus 3, right? So there must be a minus 3e. Minus 3 electron gone. 2 electron from S are gone. 1 from D are gone. So you are remain with 3d4. So you have at least what one? You have 4 electrons. So it should be a colorless. Okay, it should be a colorless. Then cobalt 3 plus. Again, electronic configuration 27. Argon 4s2 3d7. Out of this, 2 electron from S and 1 electron from D are gone. So you got a 3d6. So this cannot be colorless. It should be a colored, and it is colored. So that is why this option goes. Next, Fe3 plus. As far as Fe3 plus is concerned, atomic number of Fe is 26, right? And 3 plus, no? So electronic configuration argon 4s2 3d6. So 3 electrons are gone. 2 from S, 1 from D. You are remain with D5 system. That can be colorless. Then you got a Cr plus 3. Cr plus 3 argon 4s1 3d5. So you are removing 3 electron, 1 from S gone, 2 from D are gone. So you got 3d3 system, which is obviously having 3d electrons. That is also can't be colorless. So both A and B are gone. Okay. Next. Now C, Zn2 plus. What is the atomic number of zinc? 30. Electronic configuration argon 4s2 3d10. Out of which 2 electrons have gone. That means S electrons are gone. You are remained with 3d10. And 3d10 has to be colorless. Lastly, scandium 3 plus. We just have seen here atomic number for scandium is 21. Argon 4s2 3d1. From here 3 electron has gone. So 3 electron means both these electrons have gone. That means scandium 3 plus is D0 and Zn2 plus is D10. And as I told you, both the systems are colorless. That is why our answer here has to be option C. Okay. So that is what it for all these 3 questions. Okay. Chal, moving ahead with this. The number of moles of acidified KMnO4 required to convert sulfite ion into sulfate ion. The number of moles of acidified KMnO4 required to convert sulfite ion into sulfate ion. Now, what is sulfite ion? SO3 2 minus is called as sulfite ion. And SO4 2 minus is what? It's a sulfate ion. It's a sulfate ion. Now in SO3 2 minus, what is the oxidation state of sulfur? 3 into 2, 6, 6 minus 2, minus 4. That means sulfur must be in a plus 4. Sulfate, 4 into 2, 8, 8 minus 2, minus 6. That means sulfur must be in a plus 6. So basically sulfur is getting oxidized from plus 4 to plus 6. So how many loss of electron has happened? Loss of electrons is equal to 2. Now acidified KMnO4, right? That means KMnO4 in an acidic condition. Now we all know that KMnO4 in an acidic condition where manganese is in a plus 7, it goes from plus 7 to manganese plus 2. That means how many electron it gains? Gain of electron is equal to 5, right? So they're asking the number of moles of acidified KMnO4 required to convert sulfide ion into sulfate ion is? It is quite simple. If you take this sulfide ion into sulfate, you need to, it is losing 2 electrons and it is gaining 5 electron, right? So that means it must be 2 by 5. It is quite straightforward. Let me tell you. 1 mole of sulfate, SO3, sulfide, sorry, SO3 2 minus is going to 1 mole of sulfate, SO4 2 minus. How many electrons? 2 electrons. Then 1 mole of KMnO4 going from 1 mole of Mn plus 2 is equal to 5 electrons. So if 1 mole of this requires 2 electron and your KMnO4 is actually gaining 5 electron, that means for this you require 2 by 5 electron. It is quite straightforward, isn't it? 2 by 5. And that is why for this question, answer has to be A, 2 by 5. Okay, we have covered this kind of question in a chapter called redox reaction. Okay, chalo. Moving ahead. The higher oxidation state of transition elements are found to be the combination with A and B, which are, or let me tell you, the transition element tends to show higher oxidation state with the elements which are the most electronegative elements in your periodic table. And which are the two most electronegative elements in the periodic table? The first one is your fluorine. Second one is your oxygen. So with fluorine and with oxygen, element tends to show very higher oxidation state. Do you know the highest oxidation state shown by transition element? The highest oxidation state shown by transition element is +8. In fact, it is the highest oxidation state shown by any element in the periodic table, and that is +8. It is shown by rhenium, and it shows that oxidation state with oxygen, rhenium O4. Here your rhenium is in a +8. Now you might say, sir, fluorine is a more electronegative than oxygen, right? Then so the element should show highest oxidation state with fluorine. Then why is it showing the highest oxidation state with oxygen? See, the reason for that is that oxygen is able to form a double bond. Oxygen is able to form a double bond, and on forming a single bond with oxygen, it imparts -2 charge on itself and +2 charge on the other element. So by forming just 4 bonds, oxygen can impart an oxidation state of +8 to the other element. As far as fluorine is concerned, the valency of fluorine is 1 only. So fluorine can impart a oxidation state of -1 only. So when fluorine wants to impart oxidation state of +8 to rhenium or any other element for that matter, it needs to form an 8 bond. It needs to form 8 bond with that metal. And whenever you form an 8 bond, there's a lot of steric hindrance. And because of that steric hindrance, your compound becomes unstable. And that is why elements are preferred to show maximum oxidation state with oxygen where they can form a multiple bond. Let me show you how. See, this element shows the oxidation state like this: rhenium, double bond O, double bond O, double bond O, double bond, like that. This shape is a tetrahedral, and hybridization, by the way, is also sp3. Okay, because these are the sigma bonds. Others are what? Pi bond. Okay, now that is p pi d pi bond. That is not our concern here. I'm just need to mention here that this is how it can show highest oxidation state. Okay, sure. Moving ahead with this. Next, copper reacts with conc HNO3. Copper reacts with the conc HNO3 to give you copper nitrate plus oxide of nitrogen. oxide of a nitrogen. We don't know what oxide it is. Okay, they're asking what is that oxide. What is that oxide? See, let me tell you. See, copper, whenever it reacts with a concentrated HNO, in HNO3, the oxidation state of nitrogen is how much? It's +5, right? We have calculated it multiple times. Okay, what is the oxidation state of copper here? 0. It gives you copper nitrate, CuNO3. What is the charge on NO3? Each NO3 has -1 charge. So 2NO3 will have a -2 charge, and therefore copper has got +2 charge. So basically your copper has got oxidized. Your copper has got oxidized, right? It is losing 2 electrons. Loss of electron is equal to 2. But nitrogen was in the nitrate form here also, and it was in the nitrate form here also. In NO31 minus also, the oxidation state of nitrogen is +5. The oxidation state is same in both cases, right? Then how can it balance this? So whenever this reaction happens, the 2 nitrogen stays in the +5 and other 2 nitrogen goes in the 2NO2. So in NO2 nitrogen is in what? In NO2 your nitrogen plus H2O. Okay, that is the other thing again. How many hydrogen? 2 H2O. Okay, but that is not our point here, because here there is no change in oxidation state as such. As far as this is concerned, your nitrogen here is in a +4. So 2 nitrogens are coming from +5 to +4, which is reduction, and therefore gain of electron. So the gain of electron is how much? It's 1. There are 2 species, right? 1 into 2. So that 2 and this 2 gets balanced. So that is why, and that is how you are getting 2 NO2 there. That is why that oxide of nitrogen is NO2. Okay. By the way, whenever nitric acid, concentrated or dilute, reacts with metal, it always releases NO2. Remember that. When you have H2SO4, H2SO4 releases SO2. Okay. And HNO3 releases NO2. Okay. You need to remember this. Okay. Chalo, moving ahead. Next, the product of I minus with MnO4 1 minus in alkaline medium is, see, now whenever you have an iodine, I minus plus MnO4 minus and alkaline medium, that means OH minus. Again, this is a kind of a memory based question. Iodine is in a -1 oxidation state here. Manganese is in a what? +7, right? Now manganese from +7, it goes to MnO4 2 minus. That means it goes from +7 to +6 oxidation state. Now you might say, if it is going from +7 to +6, that means the gain of electron is just 1. So your ID should go from -1 to 0. That means I2 should be your answer. But no, that is not the case. I minus generally doesn't get oxidized to I2. In fact, going from I minus to I2, 0, it is what? It is the oxidation, that's for sure. Okay, but it doesn't get oxidized to that much level only. It gets oxidized to further +5, IO3 1 minus. Okay, iodine gets oxidized to +5 oxidation state in a basic medium when you have a magnet ion with it. This is again a memory based question. Okay, next. But this next question is not memory based. The basic character of the transition metal monoxides. The basic character of the transition metal monoxide follows the order. Okay, atomic numbers are given. Now let me tell you, whenever you have a metal monoxides, the basicity of metal oxides, any metal oxide you take, basicity of a metal oxide is directly proportional to size of metal. Size of metal. Why? Because the basicity of metal oxide is directly proportional to metallic character, right? And metallic character is directly proportional to size of metal. So what do we mean by that? Larger the size of a metal, higher will be its metallic character. Higher the metallic character, more basic will be that metallic oxide. Okay. As far as these elements which have been given here are titanium, vanadium, chromium, and iron are concerned, atomic number of titanium is given 22, 23, 24, and 26. So basically here you are going from left to right. And as you know, as we have studied the periodic table, whenever you are going from left to right, the size decreases. Whenever you're going from left to right, the size decreases. So as the size decreases, metallic character also decreases. And that is why in all this example, the titanium oxide should be most basic. Titanium oxide should be most basic. Then vanadium oxide. Then chromium oxide. Then iron oxide. So your basicity order should be like this. Where do we have this order? Yeah. TiO, VO, CrO, FeO. That is why B should be your answer. What is the reason for that? The basicity of a metallic oxide is directly proportional to metallic character, and metallic character is directly proportional to size of metal. So that was the reason for it. Okay. Chalo, moving ahead. Next, Cl2 gas. Cl2 gas is obtained by various reaction, but not by. See, when you react KMnO4 with Conc HCl, chlorine is in a -1 here. So from -1, it goes to 0 oxidation state in Cl2. So it happens here. Okay. Here, MnO2 plus HCl. Here also your chlorine goes from -1 to 0 oxidation state Cl2, and obviously some other products are also forming. Okay. As far as this reaction is concerned, here you do not get Cl2. You do not get Cl2. Now obviously you need to remember this. Here also if you perform this reaction, you get 2Kf releasing Cl2 gas. So here also you get the chlorine, but this is the reaction. You do not get the Cl2 released in that format. Okay, that is why the answer is B in that case. Next, maximum magnetic moment is shown by. Now for maximum magnetic moment, we need to find out firstly its formula. What is the formula for magnetic moment? Mu Bm is equal to, what was the formula? N plus 2 under root, right? What is mean by N? N is number of unpaired electrons. Number of unpaired electrons. Now we need to find out those unpaired electrons. First is d5. How do you write d5? 1, 2, 3, 5. d5 1, 2, 3, 4, 5. So you got 5 unpaired electrons, right? So N is equal to 5. You putting value of 5 into that. 5 plus 2. 5 plus 2 is 7. 7 into 5 is 35. So mu is equal to 35 under root 35 Bm. Okay. Let's write D6. How should be your D6? 1, 2, 3. How do you write D6? 6 electron, right? 1, 2, 3, 4, 5, 6. So you got 4 unpaired electrons. putting n into that formula. 4 plus 2 under root. 4 plus 2 is 6. 6 into 4, 24. Under root 24 bm. Then you got a d7. How do you distribute d7? 1, 2, 3, 4, 5, 6, 7. How many unpaired electrons you have? 3 only. So mu is equal to 3 into 3 plus 2. 3 plus 2, 5. 5 into 3, under root 15 bm. Lastly, d8. How do you distribute d8? 1, 2, 3, 4, 5. So you distribute 8 electrons like this. 1, 2, 3, 4, 5, 6, 7, 8. How many unpaired electrons do you have? 2 only. So no need to tell you that. 2 into 2 plus 4. 2 plus 4 into under root 8. So under root 8, under root 15, under root 24, under root 35. Oh. What does happen? Oh, sorry. Yes. So, as you all know, the highest value is shown by under root 35. That means the maximum magnetic moment is shown by d5. You can remember this. See, when you go from d1 to d5, the number of unpaired electrons increases like this. d1 1, d2 2, d3 3, d4 4, d5. From d5 onwards to d10, the number of unpaired electrons decreases like this. d6 has 4, d7 has 3, d8 has 2, d9 has 1, d10 has 0. Okay. So next time you can remember it directly instead of solving this. I made you understand, that is why I solved it. Okay. That is why the answer here is A. Okay. Sure. Moving ahead. Magnetic moment 35 is true for which of the following pair? Now we just saw here magnetic moment of 35. That means n must be how much? 5. You must have a 5 unpaired electron. So we need to check out of this 4 which has d5 system. Okay. Cobalt 2 plus, atomic number of cobalt is 27. Electronic configuration argon 4s2 3d7. So plus 2, that means these 2 electron gone. What we are remained with? d7. So d7, that means it has only 3 unpaired electrons. We just saw Fe plus 2, atomic number of Fe is 26. Electronic configuration argon 4s2 3d6. These 2 electrons are gone. You are remained with d6. N is equal to 4. It has 4 unpaired electrons. Then Fe plus 3. Fe plus 3, just look at here. You are removing 3 electrons here. So 2 electrons from S are gone. 1 electron from D are gone. So you have got D5. Right? And D5 means N is equal to 5. N is equal to 5 means magnetic moment is equal to 35. Right? That is why it must be option B. Let's check it for manganese also. Manganese atomic number 25. Electronic configuration argon 4s2 3d5, out of which it is plus 2, right? So these 2 electrons are gone. You are remained with d5, and that means this should be your answer. Sorry, not this. This should be your answer. It is also having a d5. Magnetic moment must be 35, and that is why the answer is B in this case. Next, Fe plus 3 is more stable than Fe plus 2. The reason is R. Now this is the question where more than one answer are possible. Okay, I just brought this because I wanted to cover this concept for you. Okay, the first, now you just saw here Fe plus 3. See, Fe plus 3 is a D5 system, right? And Fe plus 2 Fe plus 2 is a D6 system. Now we are not discussing how many unpaired electrons does it have, because that is not our question here. Our question is Fe3 plus is more stable. This is, they have already told us. Fe plus 3 is more stable than Fe plus 2. The reason are, see, Fe plus is D5, Fe2 plus is D6, and we know that D5 is a half filled, orbital, and we all know half filled orbital has extra stability. Half filled orbital has extra stability. That is why Fe plus 3 is more stable than Fe plus 2. In other words, the core of Fe3, the core of Fe plus 3 is more stable. That is why this is surely our answer. Next, second and third ionization potential difference. Second and third ionization potential difference is less than 11 volt electron volt, or it is less than, we don't know. Okay, see, now when you're going, this is Fe plus 2, okay, it is a D6 system, then you are going to Fe plus 3, your D5 system. So basically whenever you're going from, see, this is Fe plus 1, Fe plus 1 is what? It is also D6 system, but one electron is present in S1. So when you are going from here to here, you require some electron volt of energy, that is obvious. And when you are going from Fe plus 2 to plus 3, then also you require some electron volt of energy. Okay? Now, generally, as far as this energetics is concerned, whenever you are going to the highest oxidation state, whenever you are moving towards the higher oxidation state, the ionization energy goes on increasing. But as far as this case is concerned, when you are going from Fe plus 2 to Fe plus 3, what happens here is that system knows that it is going to more stable oxidation state. And as the system knows that it is going towards the more stable oxidation state, it is prefers to go immediately from here to there. And in the process, it requires less absorption of energy, which is rather less than 11 electron volt. So yeah, that is also the reason for Fe plus 3 to be more stable than Fe plus 2. So both B and C are the reason. For A cannot be answer. D is surely is not your answer. Why? Because the ionization potential is quite high. That is what they have said. And had that been the case, this wouldn't have been the situation then. Okay. That is why our answer here is B and C. Okay. Chalo, moving ahead. MnO4 1 minus plus X electron going to MnO4 2 minus. So they are asking the values of X, Y, and Z. Let me show you how. See, manganese oxidation state of MnO4 1 minus is how much? We have calculated it earlier. Still, we can calculate it once again. How can we calculate the oxidation state of manganese? Oxygen is in a minus 2, right? 4 into 2, minus 8. Minus 8 minus 1, minus 7. That means manganese must be in a plus. Let's look at here. Manganese oxidation state. 4 into 2, 8. 8 minus 2, minus 6. So manganese is in a plus 6. So manganese has gone from plus 7 to plus 6. So that means this X must be 1. Right? So X, Y, Z, out of which we got X, which is 1. So, and X is a 1 in a 3 option. A, B, C. But it is not in D. So D is surely not our answer. That's for sure. But we are still to get the other option, right? Yeah. Next. Ye minus acidic medium. Now they are asking the Y. See, in this second case, manganese is coming from plus 7 to plus 2. Right? That means gain of electron must be how much? Your gain of electron must be equal to 5. You're coming from plus 7 to plus 2, right? That means Y must be 5. So X is 1, Y is 5. That is present only in a B option. It is not in A. It's not in C. Okay? At the time of exam, even if you get these two, That is enough. You got your answer. No need to look at for what Z is. Okay. I'm telling you what Z is here because I'm making you understand. Because in exam, Z could come earlier before the Y. In exam, it could be XZY. You don't know. Okay. So that is why I'm making you understand. In a neutral medium, it is coming from +7 to +4. So +7 to +4, that means 3 electrons have been gained. That means Z must be 3. That is why our answer is B, 1, 5, 3. Okay, sure. Moving ahead. In the equation, M reacts with 8 moles of cyanide, 2H2O2 to give you this compound. If you look at this compound, what is the oxidation state of your metal here? It is MCN2 1 minus. It is suppose X, we don't know. Oxidation state, our charge on cyanide is -1. There are 2 cyanide, right? X -2 -1. X is equal to -1 plus 2. 2 minus 1, it's 1. Therefore, the oxidation state of your metal must be +1. Now, out of all these 3, copper can exist in a +1. Okay, but copper is more stable in +2. So copper showing +1 oxidation state is quite rare. Gold is present in +3. Mercury is present in +2. The only metal out of these 4 which shows +1 oxidation state primarily is silver. And that is why in this case the answer is silver. Okay. So moving ahead. Next. CuSO4 reacts with NH3 to give us X. Then X is what? See, whenever copper sulfate reacts with 4 moles of ammonia, it gives you this CuNH3 4 2 plus counterbalanced by SO4 2 minus. Okay, so A is for sure here. Now is it a paramagnetic? We need to check. The oxidation state of copper here is +2. What is the atomic number of copper? It's 29, right? Electronic configuration, argon, 4s1 3d 10. Now it's +2. That means you're losing 2 electrons. So 1 electron from S goes, 1 electron from D goes. You are D9 system. And in D9 system, how do you arrange the 9 electrons? 1, 2, 3, 4, 5. You arrange 9 electrons like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means you are remain with 1 unpaired electron. That makes it paramagnetic. So it is paramagnetic. So this option is also right. It is a paramagnetic. Is it a colored? Yes, absolutely. It is a colored. It's a blue colored complex. Let me take the blue colored only directly. Yeah, the color. It's a blue colored complex. Now this, some of the things you need to remember, okay? And you will remember if you have studied enough. Okay, it's a blue colored complex. And lastly, paramagnetic, yes, of magnetic moment 1.73 bm, because 1.73 bm corresponds to 1 unpaired electron, and it does have 1 unpaired electron. So all of these options are correct. So in fact, there should have been one more option, option D, sorry, option E, all of them. Okay, sure. Moving ahead, number of moles of SnCl2 required for the reduction of K2Cr2O7 into Cr2O3 in acidic medium is. See, your K2Cr2O7, let me write it further, K2Cr2O7. Here your chromium is in a +6. It is going from there to Cr2O3. In Cr2O3, oxidation state of chromium is +3. Okay, but there are 2 chromium. Each chromium is going from +6 to +3. This is reduction. But since there are 2 chromium, therefore gain of electron is how much? it's of 6 electrons. Okay, now, so number of moles of SnCl2 required for the reduction. Now, in SnCl2, your team is in a +2 oxidation state, and team goes from SnCl2 to SnCl4. It goes from +2 to +4. So you just saw your chromium is gaining 6 electrons. That means each 1 mole of K2Cr2O7 is gaining 6 electrons, and 1 mole of SnCl2 is losing 2 electrons. That means for a 1 mole of K2Cr2O7 you require 3 moles of SnCl2, and that is why here your answer should be, okay, it is quite clear. You can see here, this is the loss of electron. Loss of electron is 2, this is 6. So you need to multiply this by 3. That is why number of moles of SnCl2 are 3. Okay, so moving ahead. Which of the following reaction is possible at anode? Which of the following reaction is possible at anode? Now, whatever electrochemistry we had studied till now, you all know what happens on anode. On anode, oxidation happens. And on cathode, what happens? Reduction happens. Now, some of you might get confused here. Okay, let me help you. How can we remember? First write anode, then write cathode. Okay, then take the very first letter. Of both the processes. In the very first letter of anode is A. Very first letter of cathode comes A, C. Now between A and C, which comes alphabetically first? A comes alphabetically first, right? So you name this as 1, you name this as 2. Now between oxidation and reduction, take the very first letter. In both the cases. For oxidation, very first letter is oxygen. For reduction, very first letter is R. Okay. Now alphabetically between oxidation and reduction, or between O and R, which comes first? Oxygen comes first. Obviously, that is the ABCD you all know. So this is first, R comes later, so this is second. So first, second. Just pair it. That's it. Isn't it easy to remember? So on anode, oxidation happens. On cathode, reduction happens. It is that easy. So they have given the 4 reactions. They're asking which reactions must be happening at anode. If you look at the very first reaction, the chromium is in a +3 here. And here, 7 into 2, 14. 14 minus 2, 12. 12 divided by 2, +6. So chromium is going from +3 to +6. So this is oxidation, we all know. That means this must be the reaction which is happening on the anode, isn't it? Because fluorine cannot get oxidized. Here fluorine is going from 0 to -1. And this is reduction. And this must be happening on cathode. It cannot happen on anode. As far as this case is concerned, here oxygen is going from 0 to -2. This is also reduction. And this was never an option. So that is why A is our answer, because that is where the oxidation is happening. Yes, Menu Anudeep, you are right. 3 moles. Very good. Okay. If you have any doubt, you can ask me in the comment section. Okay. Chalo, moving ahead. Which of the following is not colored? Now, which of the following is not colored? For that, we need to survey it. We need to survey it, all of them carefully. See, this is the Nikel's complex. The charge on a single DMG is -1. You got 2 DMG, so it is -2. Nickel must be in a +2. The atomic number of nickel is 28. Electronic configuration argon 4s2 3d8. Out of which +2, 2 electrons have gone. These electrons have gone. You are remaining with D8 system. D8 system has two unpaired electrons. And having even a single unpaired electron makes your compound a color compound. Okay. Then this is cobalt, this is iron, this is aluminum. Yes, this compound has to be colorless. Now you might say, sir, why? How can you answer immediately? Because this is not a transition compound. This is a non-transition element compound, non-transition complex. And non-transition complexes are always colorless. They are always colorless. That is why this should be our answer. We don't need to look at the other options. I'm just helping you to solve it faster. Okay. And the last question from DNA block elements. The total spin and paramagnetism of ferrocyanide ions are respective. Ferrocyanide, formula for ferrocyanide is FeCN6 4 minus. It's a ferro, no? See, ion present in two oxidation state. +2, +3. Okay. +2 is called as ferrous. +3 is called as ferric. Okay. IC is attached to the higher oxidation state, remember always. And OUS is attached to the lower oxidation states. Okay. So ferrocyanide, I know that ion is present in a +2 oxidation state here. Okay. So electronic configuration, atomic number 26. It is argon 4s2 3d6, out of which 2 electrons are gone, which must be from s electrons. You are remained with d6. How do you arrange d6? 1 2 3 4 5 6. How many unpaired electrons do we have? You have a 4 unpaired electrons, but remember this is a cyanide. Cyanide is a strong filled ligand, and being a strong filled ligand, this can't be our arrangement. Our arrangement should have been like this. Let me show you. 1 2 3 4. You got a 6 electrons, right? How can you arrange them? Actually, you need to arrange them like this. 1 2 3 4 5 6. So technically you can't have any unpaired electron there. It should have been a 0 unpaired electrons, because you can't have any unpaired electron. Okay, but it is a d6 system. Let me write it once again for you. Let me show you. How can we do this? Yeah. 1 2 3 4 5 6. This electron gets paired here. This, yes, it has a 0 unpaired electron. It has a 0 unpaired electron, and paramagnetism should also be 0, but it is 0 here. And the value which I wrote here, 2 into √6, it is because of orbital motion of electron. The orbital motion of electron also contributes to the magnetic moment. But that is the out of context question right now for us. And I can only tell you that the total spin for this compound is 0. This should be your answer. You don't need to go much into this. Okay. As far as this question is concerned. Moving ahead. So that was it for the D block and A block elements. And you must have seen, we have one more chapter in today's session, that is surface chemistry. Now, most of these questions are quite easy and they are memory based questions only. Okay. Which of the following factor affects the adsorption of a gas on a solid? Adsorption of a gas on a solid is affected by critical temperature. It is affected by temperature of the gas. It is affected by pressure of the gas also. So technically it is affected by all of them. It is affected by all of them, and that is why D is surely our answer here. Next, the volume of gases NH3, CO2, CH4 adsorbed by 1 gram of charcoal at 298 Kelvin are in. See, they are basically asking the decreasing, they are basically asking the decreasing order of the volume of gas which gets absorbed by given amount of charcoal. Now see, to remember one point which I'm going to tell you. The gas which is easily liquefiable, the gas which is easily liquefiable gets adsorbed to the maximum amount. That means the ease with which gases are getting liquefied are directly proportional to the volume with which they are going to get adsorbed. Basically, the gases which can be easily liquefiable can be easily adsorbed. So as far as NH3, CO2 and CH4 are concerned, NH3 is a polar compound, we know that. CO2 is non-polar, okay, but it has some polarity in the form of delta plus and delta minus of oxygen and of the carbon. CH4 is completely non-polar. It is completely non-polar. In fact, it is called as paraffin, alkane. It's an alkane, right? It's a methane. So your order should be like this: NH3, CO2, CH4. Okay, therefore NH3, CO4, CO2, sorry, NH3, CO2, yes, that is the order C. ठीक है, as I told you, अगर gases easily liquefy हो सकते हैं तो वो easily adsorb भी हो सकते हैं. Remember this point always. Okay, it will help you solve such a kind of question if it comes into the exam. Next, the heat of physics option. The heat of physics option lie in the range of, now you need to remember this. The heat of physics option lie in the range of 20 to 40 kilojoule per mole. And heat of chemist option lie in the range of 200 to 400 kilojoule per mole. Almost 10 times of physics option. Okay, but they are asking the physics option, so this is our answer. Okay, sure. Moving ahead, colloids can be purified by. Now colloids cannot be purified by condensation, baptization, coagulation. Colloids can only be purified by dialysis. As I told you, memory based question. Milk. Milk is an example of what? Sol? No. Is it a emulsion? No. Is it a foam? Surely not. It's a suspension. It's a suspension of a fat. It's a suspension of a solid fat into liquid, which is oil. Sorry, which is a water. That is called as a milk. Lastly, fog. Fog is a colloidal system of. So we all know what fog is, right? In fog, your gas has been captured into the solid. In fog, the gas has been captured into the solid. Therefore, fog is a colloidal system of a gas in a solid. Okay. So moving ahead. Oh, sorry. I made a mistake. No. It is not solid. This is not answer. Sorry. Your fog is actually a colloidal system of a liquid in a gas. The liquid has been captured into the gas. That is your answer. Okay. Sorry, my bad. Next, adsorption. Absorption is a multi-layer in case of. Now we had studied enough that as far as chemist option is concerned, chemist option is always monolayer. Why chemist option is monolayer? Because chemist option is nothing but like a chemical reaction, or I would say it's a chemical bond. Whenever a chemical bond forms with the upper layer of adsorbent, you do not have the another layer to form a bond. That is why chemist option is always monolayer, but physics option is always multi-layer because it is not forming a bond. It is just getting deposited there. So that is why physical adsorption is always a multi-layer. Next, a liquid is found to scatter. A liquid is found to scatter a beam of light. Liquid is found to scatter a beam of light but leaves no residue when passed through the filter paper. A liquid is found to scatter a beam of light but leaves no residue when passed through a filter paper. The liquid can be. Such a liquid can only be a true solution. It can only be a true solution, and then only it can happen. Next. Now, in fact, the last questions of today's session. Given below are the few electrolytes. Given below are the few electrolytes. Indicate which one among them will bring about the coagulation of gold. The coagulation of a gold soul quickest. The coagulation of a gold soul quickest and in the least concentration. See, for any compound or for any soul to get coagulate, you need to take the compound which should provide a maximum number of ions. The compound which is having a maximum number of ions can make gold soul or any soul coagulate faster and obviously in the least concentration. That is why, as far as these options are concerned, we need to check the compound which provides the maximum number of ions. The compound which provides a maximum number of ions should be able to coagulate the gold fastest and in the least concentration. So NaCl releases Na plus Cl minus. So how many number of ions it produces? Only 2. 2 ions it produces. MgSO4. How many ions it produces? Mg2 plus SO4, 2 minus. So ions are 2 and 2. There are basically 4 ions. Okay. Then Al2SO4. Al2SO4 gives you 2Al3 plus 3SO4, 2 minus. So 3 into 2, 6. 6 plus 6, it gives you 12 ions. It basically gives you not 12, 12 charges. And this gives you K4 plus Fe, CN6, 4 minus. So 4 plus 4, 8. So this is giving you 12 charges. That means this is the compound which should be able to coagulate the gold to the quickest, and it is only the compound which will require in a least concentration for that to make happen. Okay, that is why in this case our answer is C. Okay, now the last question. The minimum concentration of an electrolyte required to cause the coagulation of a soul is, we just saw that now. The minimum concentration of an electrolyte required to cause the coagulation of soul is called as flocculation value. That is called as flocculation value. And that is what is for today's session. I hope you really enjoyed this session. If you really do, please like this video, comment on it. If you have any doubt, you can ask me there. I can answer it in the next lecture. And please subscribe to Practically Live on YouTube for more such courses, because if you subscribe to it, if you like it, if you comment it, it will only inspire us, it will only motivate us to bring more such interesting courses for you. Secondly, you can also download our app from Play Store and Apple Store. Okay, you can log into it, you can check into it. You will be very happy to see that we have courses in the robotics, chess, coding. Okay, you will really enjoy it, all those courses, and we have provided all those courses in a visually, I would say a 3D based model. That means you will be enjoying those videos in a 3D based system. Okay, it's like a virtual system. You can just download it and you can explore it. You will really enjoy it. Okay, that's it for today's session. Bye bye till the next session.